Morning. Quadratic sequences, finding the nth term of quadratic sequences. These are sequences where the gap between each number isn't the same. So we've got to try something different. If I look at this sequence here, I've already put the gaps in. So from 8 to 11 we've got a gap of 3, 11 to 16 we've got a gap of 5, 7 and 9 and so on. In other words, the gap isn't 3, 3, 3, 3, 3 like we've had before. That would have been easy to solve. The first thing that I do, if I've got a gap going up, that tells me it's going to have an n squared in it. Okay, a quadratic. So what I would always do first of all, when I've got a sequence like that, I'd write out my square numbers. So my first square number, 1 times 1 is 1. Second square number, 2 times 2 is 4, 9, 16 and 25. So that's n squared. Now, what I'm going to do here, I'm going to have a look to see if there's a link between my squared numbers and the sequence I've got. So, 1 to 8, I add 7. 4 to 11, I'm adding 7. 9 to 16, that works very well. So, the sequence then would be n squared, which is my square numbers, plus 7. Okay, so the answer is n squared plus 7. That one's quite easy. So I can do that using my quick shortcut. See if it works for this one. So I've got minus 5 going to minus 2 to minus to 3 to 10 to 19. Let's quickly write my squared numbers in there, see if there's a link. I've got 1, 4, 9, 16 and 25. Does it work? 1 to 5, I'm adding 6. 4 to minus 2, I'm adding 6. Not adding 6, am I? I'm taking away 6. 1 to minus 5, I'm taking away 6. 4 to minus 2, I'm also taking away 6. 9 to 3, take away 6, 16, and so on. Yes, it does work. So that would be n squared minus 6. So that's one way of doing it. Always try that first of all, because you might have a shortcut and save yourself a lot of work. If that doesn't work, so for example, let's put my little sequence here as well. I'm going to have my 1, 4, 9, 16, 25. Is there a link? 1 to minus 1, I take 2. 4 to 5, I'm adding 1. 9 to 15, I'm adding, well, that's all over the place. So that shortcut method won't work. We've got to think of something else. So what we do is we work out, first of all, the difference between each of these numbers. So I'm going to work out my difference between minus 1 and 5. In other words, what is the gap between minus 1 and 5? The answer to that is 6. Gap between 5 and 15 is 10. And then the gap between 15 and 29 is 14. And then the gap between 29 and 47 is 80. So, got to do something else now. Still not solved it properly. So 6, 10, 14, 18, they're not going up all in sort of with an even gap. So I'm going to try what's called the second difference. So what I do, I find the difference between this row of numbers. Now, so 6 to 10 then, I now have a difference of 4. 10 to 14, I've got a difference of 4. And 14 to 18, I also have a difference of 4. So that's working now. My second differences are all the same. What I do now is I take my second difference of 4, which I've worked out along here, and I'm going to divide it by 2. And that gives me 2. The answer to this now means that I've got a sequence with 2 n squared. Okay, so with working out that second difference, I'm halving it. That will be the number in front of my n squared. So what I'm going to go back to do now is I'm going to write 2n squared above my sequence here. So let's rub this little line out here. So 2n squared, so in other words, double 1 is 2. 2 2s are 4. Double it, you get 8. 3 3s are 9. Double it, you get 18. 4 4s are 16. Double it, you get 32. And 5 5s are 25. Double it, you get 50. That is 2n squared. Okay, so it's square a number, then doubling it. Now I'm going to have a little look if there's a link between these numbers here my red 2n squared and my black original sequence line. So, how do I get from 2 to minus 1? I take away 3. How do I get from 8 to 5? I take away 3. And so on. I'm taking away 3 each time. So my sequence is going to be 2n squared, take away 3. So 2n squared, take away 3. And that's how we can crack one like that. So we've got the easy approach there, and then we've got the slightly more difficult one. Feel free to stop the video, rewind and look at little bits that you don't get. Let's try one more. Here's my sequence: 5, 14, 29, 50 and 77. First thing we've got to do, find a difference between the numbers. So from 5 to 14, the gap there is 9. 14 to 29, I've got a gap of 15. 29 to 50, I've got a gap of 21. And 50 to 77, I've got a gap of 27. Now we do the second difference, so if I'm the gap between these numbers here, 9 to 15 is 6, 15 to 21 is 6, and 21 to 27 is also 6. I now take my 6 and I divide it by 2 to give me 3, because I've got the same second difference all the way across. So that means my sum is going to be 3n squared. Now I've got to work out the something number, haven't I? So let's have a little look. So 3n squared. 1 is 1n squared, isn't it? So that's 3. So n squared 4, 12. So 3 times 4 is 12. Let's look out over there. You see, so I've got my n squared. I've got 1, 4, 9, 16, 25. So I'm just going to multiply each of those numbers by 3 to get 3n squared. So 9 3s then, 27. 16 3s are 48, and 25 3s are 75. That is 3n squared. Now I look, see if there's a link between 3n squared and the sequence below. I'm adding 2, adding 2, adding 2, adding 2, adding 2. So this is 3n squared add 2. So 3n squared add 2 would be the answer to that particular sequence. Okay, so very tricky stuff there. Obviously starting off, see if you can get away with it, the easy bit. 2n squared, 3n squared sequences. As I said, can't repeat often enough. Stop the video, rewind it a little bit if you don't get it, because this is a tricky one. So here we have it, is quadratic terms finding the nth term rule.